Hello and welcome to lesson number 3 in Unit 0 in our grade 10 academic math class. This is solving polynomial equations. Now, it says here in the introduction, recall that solving polynomial equations means finding values for the variable, or variables, in this case for a single variable, that will result in the left side of the equation being equal to the right side of the equation. How do we do that? Essentially what we're going to do is isolate the variable term. And again, it says that right in the little introduction. We want to isolate the variable term by using inverse operations. So we're following BEDMAS, but we're following it in reverse. Think of BEDMAS as wrapping up a variable that we're trying to figure out. Doing BEDMAS in reverse exposes what the variable's value is. Now I've worked example number 1 out, so let's just talk through that. The question itself is 6 times y minus 3, that binomial in brackets, minus 2y equals negative 2, bracket, 3y minus 2, again, the binomial in brackets. Now the first thing you're going to want to do in a case like this is expand it out. And we expand it out in the case of the first term by taking that 6 and multiplying it by each term inside the bracket. So 6 times y gives you your 6y, and then 6 times negative 3 gives you negative 18. Then minus 2y is fine as it is, and then on the other side of the equation we do the same thing. Negative 2 times 3y gives us negative 6y, and that negative 2 again times this negative 2 in the bracket results in a positive 4. So things to watch for here, just the signage, making sure that when you're multiplying by negative 2, most people will get this one right. They'll do negative 2 times positive 3. They'll recognize that should be a negative 6y. Sometimes or often, students will then forget that this same negative 2 is being multiplied by this negative 2. They'll mess up that positive sign there if you were going to make a mistake. At this point, once we're done the expansion, what we have is 3 terms on the left, 2 terms on the right. We have 2 variable terms on the left, the 6y and the minus 2y. So I'm going to change up my colors here. And what we're going to do now is combine the like terms before we start transposing terms. And transposing terms is just a fancy way of saying we're moving terms around from one side of the equation to the other. So before we do that, however, we might as well gather together these like terms here. 6y minus 2y results in 4y. And now we're down onto the next line. Same as before, we have 4y minus 18 equals negative 6y plus 4. Our idea here is to get all the variable terms on one side. Let me just grab some color. So what we're going to do is we are going to transpose negative 6y over to join the 4y on the left side of the equation. Now how do we do that? On the right side of the equation, it's minus 6y, and we undo that. The opposite operation of subtraction is adding. So we're going to add 6y, but we're going to add 6y to both sides. The reason we do that is we are required to keep the left side of the equation equal to the right side. So we're going to do that by doing the same thing to both sides of the equations. Interestingly enough, on the left side of the equation, what happens when you are on the right side of the equation, rather, when you have minus 6y and then you add 6y, essentially now this term has been done and then undone. It doesn't appear anymore on the right side of the equation. However, on the left side of the equation, you can see here that we've retained our 4y plus 6y. And we're going to simplify that in a moment. In the same step, I'm going to transpose negative 18 from the left side of the equation to the right side of the equation to join the other constant term plus 4. So how do I undo subtract 18? I'm going to add 18. But again, to keep this equation equal, I'm going to add 18 to both sides. So what you're seeing here, if we look to our next line, this one here, what you're seeing is we have our 2 variable terms on the left now, our 2 constant terms on the right. We are going to gather together those terms. 4y and 6y gives us our 10y right here, and our 4 plus 18 gives us our 22. At this point now we have 1 term on the left, 10y, 1 term on the right, 22, but we haven't isolated our variable yet. We've isolated our variable term, 10y, but now we need to get to just the y. We do that by recognizing that 10y is being multiplied by 10. And how do we undo that? We divide by 10. But again, must do it on both sides to keep it equal. So we have 10y over 10, which of course is just a y, and then we have 22 over 10. Now again, you know I'm not a big fan of mixed numbers. You don't want to turn this into a mixed number. You want to keep it in as an improper fraction, but we do and must reduce it to its lowest terms. So 22 over 10, I recognize that both of those are divisible by 2. Which then results in our y value being equal to 11/5. Now again, technically speaking, 22 over 10 isn't incorrect. However, reducing things to their lowest terms is a common math practice, and it's something that you want to be doing every single time you have an opportunity to do so in your final answers. So hopefully that example made sense and that you were able to follow along. What we're going to do now is do a formal check. Now a formal check, and you can see I've sort of set it up over here, our formal check gives us our left side and our right side. And the check wants us to prove that the value we found for y, 11/5, is indeed, or will indeed make the left side of the equation equal to the right side. So we test that by substituting into these expressions our value for y, which is 11/5, and then we are going to evaluate it. Again, this calls right back to lesson number 2 that we were doing before. So let's work through this. Here we have our 6, and inside the brackets now we have, instead of a y, we have 11/5 minus 3, and there's our minus 2, and there's our 11/5 again. So I'm going to work through the entire left side, and then we'll go have a look at the right side. So here we have 6 multiplied by 11/5 minus 3 in a bracket. Now what we need to do is we need to get a common denominator in there so that we can simplify that. What we'll want to do is recognize that our common denominator here is going to be, this. You can think of this as a 3/1 if you prefer. We need to multiply both the numerator and the denominator by 5 to get a common denominator. So let's write that out. There's our 6, and here we have our 11/5 minus, and that's 3 times 15 for our, or 3 times 5 rather, for our numerator. That's 15, and our denominator is still 5, minus 2. Now this, again, we can think of this as a 2/1 times an 11/5 if you prefer. Let's move to our next line and we'll simplify that. So again, for ease here, I'm going to write this as 6/1 multiplied by, now we have 11/5 minus 15/5. That's going to give us -4/5. And there's our minus 2/1 times 11/5. So we are going to now do the multiplication necessary. We're going to do this multiplication and we're going to subtract this multiplication from it. So is there any reducing that we can do in our first term that we're multiplying? There is not. So we are going to have numerator times numerator, which is going to give us -24, and denominator times denominator, 1 times 5, that's going to give us -24/5. And we are going to subtract. Any reducing we can do in this fraction? There is not. So we are going to have minus numerator times numerator, which is -22, over denominator times denominator, that's going to be 5. Now what's cool is that we already have a common denominator here, which is nice. So we are going to do this last little bit of math, this little bit of combining. We have -24/5 minus another 22/5, that's going to give us -46/5 as the answer on our left side. Now again, I want to get you into the habit of recognizing that ending up with an answer like -46/5, while it might not be a nice looking number, as some of your math teachers might have designed for you in the past, there's nothing at all to indicate that we've made an error here along the way, just by virtue of it being kind of gross to look at. So let's move forward and we'll see how we do with the right side of the equation. Right side's a little simpler. We have there our -2, and here we have 3. And I'm going to write this as a 3/1, just knowing that this is going to be 11/5 that we substitute in, minus 2. And I've added some square brackets in there, but it's just to help, it's just for clarity. So now let's, as before, do any reducing we need to do in our first term here that, that will help us along the way. There isn't any reducing we can do, so let's do numerator times numerator. That's going to give us 33 over denominator times denominator. That's going to give us 5, and minus 2/1. Now, as before, we need to find a common denominator. We recognize here that the common denominator is going to be 5. So we need to multiply in our second term, both the numerator and the denominator, by 5. So let's move along. Whoops, -2. Here we have our 33/5 minus, numerator of course would be 10, denominator would be 5. There we go. Let's simplify the contents of the bracket. At this point, again, fortunately, we have the same denominator. So 33 minus 10 gives us 23/5. And now we are going to multiply. Now again, recall that this is -2/1. No reducing that we can do here. So now it's just numerator times numerator, which is -46, over denominator times denominator. That's going to be 5. And as we look here, you can see that we have -46/5 equals -46/5. The proper notation at this point is to say, since the left side equals the right side, therefore y is equal to 11/5. And that is our proper way of writing this out. We have a couple more examples here to work through, but we are going to work them through in our next video. So the part 2 is going to be coming up. Hang in there, and we'll see you in part 2.